All right, so for example 4, they want us to find the domain of f divided by g of x. We have our two functions, f of x is square root of x, g of x is the square root of 4 minus x squared. So what we can do is we can set up our fraction or quotient where we're going to take, f of g of x is, and because they are both square roots, what we can do is we can make it one large square root. It's kind of like the distributive property, just kind of going in reverse because they are both square roots, but we can make it x over 4 minus x squared. And then before we do anything else, what I'm going to recommend we do is go ahead and factor that denominator, because then that's going to allow us to get our critical point. So we have the square root of x over, this is a difference of squares, 2 minus and 2 plus x. So now we have, for this one, we're going to end up with 3 critical points. We have a critical point for the numerator, which is an actual x-intercept 0 at x equals 0. Then we have our 2 restrictions, because they're in the denominator, where x cannot equal positive and negative 2. Now, to actually set up and find our domain, we can use a number line, and then negative 2, positive 2, 0. Because we are working with a radical, we are looking for where the expression is greater than or equal to 0. So at 0, because it is in the numerator, we can use a filled in dot there at both positive and negative 2, our restrictions. We are going to need open dots. Now from here, what we can do is, use test values, use something like 3 and negative 3 on the outer parts, negative 1 and positive 1 on the inner parts, and then, from here, just plug these values back in. I'd probably go ahead and use the original function here. When you plug 3 in, it's square root of 3 over 4 minus, 3 squared is 9. So this becomes the square root of 3 over negative 5. Well, that's false. So we aren't going to be shading here. When we go ahead and plug 1 in, square root of 1 over 4, 1 squared is 1, so 4 minus 1, that is a positive value. Square root of 1/3. So that one is true. Because it is true, we'll go ahead and shade in between there. Now, when we use negative 1, the square root of negative 1 over, and then 4 minus negative 1 squared is 1. So 4 minus 1 is 3. Again, this one is negative, so that's going to be a false interval. And then last, when you plug in the negative 3, you end up with negative 3 over 4 minus, since negative 3 squared is 9, 4 minus 9, negative 5. Well, this one, because they are both negative, does turn into positive 3/5. It is, greater than or equal to 0. Because of that, that is our last interval there, which is true. So for the domain of f divided by g of x, that quotient, well, we've got 2 intervals where it is true. So our first interval, just going from left to right, negative infinity to negative 2, open dot, so that's going to be not included, so parenthesis there. Then union with starting at 0, since it is a closed dot, 0, 2, again, open dot, positive 2. So there is that one. Now, good news is when we ask you to find the domain of g divided by f of x, well, all that's going to do is flip our fraction, take the reciprocal of it. So I'm going to use the one that's already factored. So now the 2 minus and 2 plus x are in our numerator over x. Well, The only thing that changes up here with the critical points, and I'll even jot down that that's, what we have there. Now our critical points down here are going to be, since x is now in the denominator, x cannot equal 0. X now can equal 2 and -2. We're going to have the exact same values on our number line. Good news is we do not have to retest anything because the positives and negatives won't change. It'll just be a matter of all of the fractions are flipped. Now, though, because these are zeros in the numerator, now we're going to have closed dot there, open dot at 0, closed dot at -2. So you can see each of your dots have changed, and then because again this expression has to be greater than or equal to 0, slide that over so you can see that. So again, now it'll be shaded there where your shading won't change. All that would happen, this would be the square root of 3, this would be the square root of -5/3, this would be the square root of -3, this would be the square root of 5/3. So to wrap this one up, the domain here, -infinity. Now, instead of parenthesis around that -2, now it's a closed dot bracket. Again, just your parenthesis and brackets. Those are going to flip-flop where they are. 0 is no longer included. 2 is. So that wraps up day 1 from section 1.7.